All right, this is the answers for the fourth problem set from Chapter 4, Systems of Equations. We start off with 4-8, which is making a scatter plot, drawing a line of best fit, and then using it to predict a score. So the AP score, I'm going to let that be on the x-axis, and the final percent, I'm going to let that be the y-axis, and I'm going to set up my axes. So AP score, it looks like it counts by ones and it just goes up to 5. Y-axis goes up to 100, so I'm going to need, maybe I'll count by tens on that. And I chose to scale my x-axis by like skipping ones just to make my graph a little bit easier to read. All right, so now I'm going to enter my points. So AP score of 5 gave a final percent of 97. So I can't see exactly where it is, but I'm just going to estimate a little more than halfway between 90 and 100. 1 is up at 70. 4 is at 84. Skip ahead for you guys. All right, so here's what my final scatter plot looks like. Next, they tell you to draw a line of best fit. So a line of best fit is just a line that goes through the data points that kind of tries to show the general trend. So if I drew a line like that, that would not show the general trend. A line would need to have somewhat the right slope. So like that looks pretty decent. I can kind of shift it up and down and see where it feels good. But that feels pretty good to me. We're going to find more precise ways to do this in our next unit. For right now, you're just eyeballing it. Okay. And then they ask you to write the equation of that line. So once again, I just drew that line by like trying to sort of get the right slope and then put it in the middle of the data points. Now, to find the equation of this line, I'm going to do that in y equals mx plus b form. There's various ways you can do this. I'm going to do it by picking a couple points to use. So looking at my graph, I see that my line went basically through this point and this point. Now yours may not actually go through points, in which case you'll just need to use your graph and like estimate. So like find some spots where maybe it goes through the blue grid nicely, or just estimate. It's fine. But since I have a couple points that it goes through, I'm going to use those. So this one was 163, I can tell by looking back at my table. And this one is 590. So I'm going to use those as my 2 points to write the equation of my line. So x1, y1, x2, y2. I'm going to do slope formula, where m equals y2 minus y1 over x2 minus x1. So y2, so 90 minus 63 over 5 minus 1. Oops. 90 minus 63. And that gives me 27 over 4, which is approximately, or actually it's exactly 6.75. Now, my line doesn't go exactly through those points, but we're going to say it's good enough. So 6.75. So y equals 6.75x, and then plus b. Now, I probably should plug one of my points back in here, but my line happens to just really go exactly to 60. So I'm just going to say plus 60. This is just a homework problem. We're just estimating. This is not a precise equation, so it's fine. Okay, then I'm going to, the final thing they ask you to do is to predict the final exam score of another Smallville High School student who scored a 3 on their AP test. So I'm going to plug in 3 for x and see what I get for y. Because remember, x equals my AP score, y equals the final percent. So y equals 6.75 times 3 plus 60. And when I do that, I got y equals 80.25. If I look on my graph and I go up from 3, I'm just below 80. So my equation's not perfect, right? According to my line, it actually should have been more like 79. I got 80.25, close enough. Okay, on 4-81, we're going to solve by elimination. That's what I'm going to pick to do. So because when I add them together, my x's are just going to disappear. Woohoo! That gives me 9y equals 3. Divide by 9, and I get y equals 1/3. I plug that back in to one of these equations. I'll pick the top one. Negative 2x plus 3 times 1/3 equals 1. 3 times 1/3 is just 1. Negative 2x equals 0. Divide by negative 2, and x equals 0. I'm then going to check by plugging into the other equation. So 2 times 0 plus 6 times 1/3 equals 2. 0, 6 times 1/3, that's like 6/3, which is in fact 2. So that is a true statement. So 0, 1/3 is our answer for 81A. B is all set up for substitution, so I'm going to replace negative 3y in the spot of x. So y equals 1/3 times negative 3y plus 4. 1/3 times negative 3 is just negative 1y plus 4. I'm going to add y to both sides, and I get 2y equals 4. So y equals 2. I plug that back in. So x equals negative 3 times 2. Oops, that's positive 2. So x equals negative 6. Plug that into my equation. 2 equals 1/3 times negative 6 plus 4. 1/3 times negative 6, that'll be negative 2 plus 4. That is a true story. So negative 6, 2. On C, we have 3x minus y equals 7. So y equals 3x minus 2. I'm going to substitution again. Put that in place of the y. So 3x minus, in parentheses, 3x minus 2 equals 7. So 3x minus 3x plus 2 equals 7. Those are going to cancel. I just get 2 equals 7. That means no solution. Unfortunately, there's no way to check that answer other than just going back over your work and making sure that it looks good. Then on D, I could do this either using substitution or elimination. I'm going to do substitution and solve the top equation for x. So x plus 2y equals 1. I'm going to subtract 2y from both sides so that x is alone. Negative 2y plus 1, and then I'll replace that in to the other equation. So 3 times negative 2y plus 1 plus 5y equals 8. So negative 6y plus 3 plus 5y equals 8. I'll give me negative y. I'll subtract a 3 from both sides equals 5. So y equals negative 5. And then I plug that in. So x plus 2 times negative 5 equals 1. It's supposed to be a 5. X minus 10 equals 1. Add 10 to both sides. X equals 11. Plug that back in. So 3 to check times 11 plus 5 times negative 5 equals 8. So 33 plus negative 25 equals 8. That's right. So 11, negative 5 is my answer. All right, so the fruit pie recipe calls for twice as many peaches as nectarines. Twice as many peaches as nectarines. So that means that if I take the number of nectarines and I multiply it by 2, that gives me the number of peaches. Twice the number of peaches as nectarines. Yes. If it takes a total of 168 pieces of fruit, so nectarines plus peaches equals 168, how many nectarines are needed. So we'll solve this using substitution. So n plus 2n equals 168. And I need to do 168 divided by 3. That gives me 56. Look, I don't even need to plug in for the other variable. I probably should to check my work, but nectarines equals 156. All right, for 84, I got a lot of questions on this one during problem set work time. So we need to remember how functions work. So we're trying to find g of 5. That is not the same as g times -5. We're doing g of -5. So that means I put the -5 in place of all the x's. So g of -5 equals -5 cubed minus 2. So g of -5 equals -125 minus 2. So g of -5 equals -127. This is the same thing as saying that in the rule y equals x cubed minus 2, when x equals -5, y equals -127. This was like chapter 1 stuff. Long time ago now. On B, I'm going to need to put the -5 in place of the x. So g of -5 equals 7 plus the square root of 4 minus -5. Subtracting a negative, we know that is just like adding, so this is really the square root of +9. Square root of 9 is 3, so 7 plus 3, so g of -5 equals 10. On C, g of x equals the cube root of x plus -59. So the cube root of -5 minus 59, which is -64. Now, cube root, that means something times itself 3 times. Well, 4 times 4 times 4 gives me 64. But I need a -64. -4 times -4 times -4. That would be a 16 times -4 would be -64. So g of -5 equals -4. Because -4 times itself 3 times gives you -64. And that's the meaning of a cube root. D, g of x equals -4 times the absolute value of x minus 1. So -4 and then -5 minus 1. So -5 minus 1 is -6. So I've got the absolute value of -6, which is just 6 times -4. So g of -5 would equal -24. All right, and on 101, you're told to make a graph, but we don't know any shortcuts for graphing parabolas yet. You will learn some, but for now you just need to make a table. So these numbers all look kind of small and reasonable, so we're just gonna go from -3 up to 3 for our x values. And then we are going to evaluate this equation for those x values to get our y values, and then we'll plot those points. So when x equals -3, that's negative and then -3 squared plus -3 plus 2. So -3 squared gives you 9. Notice how I put this in parentheses, right? The squaring happens first. This negative is going to happen after. So it's going to be -9 minus 3 plus 2, -12 plus 2, that equals -10. And do it again. Y equals -2 squared minus 2 plus 2. I just switch it to a -2 instead of a plus negative. I hope that's okay. And then that gives me -2 squared is 4. We still have a negative outside. -4 minus 2 plus 2. So that would be -6 plus 2. That would be -4. Keep going. -1, -1 squared minus 1 plus 2 equals -1 minus 1 plus 2. That's going to be 0. When I plug in 0, 0 squared plus 0 plus 2, that's just going to be 2. I do 1, so negative, and then 1 squared plus 1 plus 2. So y equals -1 plus 1 plus 2. It's just 2. Plug in a 2, -2 squared plus 2 plus 2. So -4 plus 2 plus 2 is going to give me 0. And hey, look, it's turned around. The next one's going to be -4. All right, now I need to graph these points. All right, so I look at my table to decide what scale to use. I know on my x values, I only need to go from -3 to 3. And on my y values, I need to be able to go all the way down to -10. And I don't need to go above 2. So I have kind of a little bit of a lopsided looking graph there. So now I plot my points. So -3 is down at -10. -2 is at -4. -1 is 0. When x is 0, y is 2. 2, 0, -4, -10. But if I try and connect these, it sort of looks like a parabola, but then it like flattens off at the top, and that doesn't feel right to me. But if I look at this, I can sort of see that it's probably going to do that. To figure out what that number exactly is, I would just need to plug in 0.5 for x into my equation. So I would do y equals -0.5 squared plus 0.5 plus 2. So 0.5 squared is 2.5, so -0.2, or sorry, 0.5 squared is 0.25. So -0.25 plus 0.5 plus 2 would give me 0.25 plus 2. So that would be 2.25, which if I look at my graph, that's about what it looks like, right? It's like a 2.25, roughly, up there. But what I really want you to make sure is that you've connected your points. It sort of looks rounded as much as possible. Could have arrows down at the bottom over here, something like that.